Welcome back. Next up is Adarsh. Adarsh is a no-nonsense, no BS IoT analyst, and he will drop some truth bombs on the market for you. Enjoy this talk and brace yourself.
Good day, everyone. Thanks for joining the session, LPWA Hype versus Ground Realities. In this presentation, I'll try to give you an overview of the LPWA network's adoption in key regions and also vertical IoT applications, with a bit of a focus on Lora. The data I'm sharing with you here today are high-level research findings from my recently concluded report on the LPWA market. To briefly introduce myself, my name is Adarsh Krishnan. I'm a research director at ABI Research. For those of you who are not familiar with ABI Research, we are a leading provider of market foresight and advisory services, and for over 3 decades have provided strategic guidance to enterprises on the most compelling transformative technologies. To start, let's have a quick look at what has been achieved so far by the market. By the end of the last decade, we've witnessed a rapid expansion in the geographical footprint of LPWA networks, which were driven by network deployments from telcos, cable MSOs, other communication service providers, community-based networks, and private networks deployed by enterprises for their own IoT implementations. Today, LPWA networks have a strong global presence, with networks available at various stages of commercial deployment in key regions. The slide here provides a snapshot of the progress so far in public network deployments and also provides you with a glimpse of the device ecosystem, especially around the 4 mainstream LPWA network technologies. So if we look at cellular LPWA technologies, there are 155 networks today in 59 countries. Of these, there are 50 LTM networks and 105 NB-IoT networks. Coming to LoRaWAN, there are 148 LoRaWAN networks in 162 countries, and with Sigfox, there are 70 networks in 70 countries so far. When it comes to multi-regional LPWA network roaming, this has been a bit of a challenge in the past, and Sigfox has been one of the only available networks that have capability to support global roaming, with also LoRaWAN offering regional network roaming, especially in Europe in the past. However, this week, LoRa Alliance has announced LoRaWAN roaming in over 27 countries. This is fantastic news, especially for solution vendors that want to deploy and scale their LoRaWAN solution in multiple countries using a single SKU design. And this would also start to drive the momentum for asset tracking applications using LoRaWAN. When it comes to cellular LPWA network, there has been network roaming available over the last year in over 20 countries. But however, there is still a lack of clarity on the commercial offering when it comes to network roaming. It's also worth noting, as networks have become commercially available, the number of certified end devices for these corresponding technologies have also risen in the last 2 years. Now, when we talk of end devices, here we're not including modules, gateways, and other hardware equipment, but refer to only certified end devices or end nodes. We have Sigfox with over 390 certified devices, followed by LoRaWAN with 162 certified devices, and cellular LPWA with 124 devices. Now, we can see that commercial availability of networks and the growing number of end devices have clearly reduced the time to market for IoT solution and have subsequently led to growth in connections. I'll dive a little bit deeper into the connection growth in the next slide. At the end of 2020, there were in total 200 million LPWA network connections globally. Of this, legacy proprietary LPWA network technologies, and here we refer to LPWA technologies that are purpose-built for specific vertical M2M and IoT application, accounted for almost 45% of all LPWA connections. This is closely followed by connections from NB-IoT LoRa, LTM, and Sigfox in that order. Most of the global LPWA connections, interestingly, the growth in the last 3 years have actually originated from the APAC region, and more specifically have been driven by IoT adoption in China. In 2020, China accounted for nearly 93% of all NB-IoT connections and 75% of all LoRa connections. This early growth for these technologies in China have clearly helped propel NB-IoT and LoRa to emerge globally as leading LPWA networks for cellular and non-cellular LPWA respectively. While China has been an early growth market for LoRa, IoT implementations using LoRaWAN in Western Europe, East Asia, India, and North America are also starting to gain momentum. In the next slide, we look more closely at LoRa connections growth by key regions. As I mentioned before, the Asia-Pacific region is the largest market for LoRa. LoRa benefited from its early foothold in the Chinese market and even had a 12 to 18 month head start on NB-IoT in the region. Its growth has mostly been driven by metering applications, and especially its adoption in water and gas meters, and also some environmental sensing use cases. While metering applications, we believe, will continue to see some growth in the region, majority of the future growth will be actually driven by condition monitoring and asset tracking use cases. In the next 5 years, LoRa connection growth in the APAC region will also be less driven by its adoption in China and more from IoT implementations in Japan, South Korea, Australia, and India. When we look at the other regions, Europe and North America are the next two biggest regional markets. But surprisingly, these two markets have only contributed around 16% and 6% of the global connections at the end of 2020. The growth in these two regions have been much below market expectations, and this is more so considering the large investments that have gone into building nationwide public networks, at least in Europe. Now that said, last year, LoRa connections in Europe witnessed nearly double-digit year-on-year growth, and more interestingly, we started seeing public network connections growing by over 40%. In North America, the adoption has been much slower than expected. The connection growth in North America, at least until 2020, has largely come from private campus networks that have been used to monitor the health and condition of assets. However, we believe North America will emerge as the second biggest market by 2024, even beating Europe, mostly driven by its adoption in applications such as smart home, condition monitoring, and asset tracking. So in this slide, we are looking at the LoRa connections from a slightly different perspective by analyzing the LoRa connections by network type. So here, when we talk of public networks, it's mostly using just LoRaWAN, while private networks could be a combination of either using LoRaWAN or have a proprietary implementation where they use LoRa in the physical layer and then have a proprietary protocol running in the MAC layer. In 2020, private networks accounted for over 90% of LoRa connections, making it pretty clear that private networks have been the most popular choice for IoT implementations using LoRa. One of the reasons that can be attributed to the growth in private networks is also LoRa's early traction in the smart metering vertical. Now, utilities have traditionally been key proponents of private networks, and with LoRa, the simplicity of network deployments and lower cost of network infrastructure hardware have clearly helped further accelerate this particular trend. However, globally, we are starting to see this change, at least in 2020. LoRa connections from public networks grew at around 35% compared to private networks, which grew at around 20% last year. Public network connections growth, at least for LoRa, have largely been driven by smart city applications, tracking, and condition monitoring use cases. That said, the next 5 years, private networks will still continue to have a majority share of LoRa connections, mostly driven by its adoption in the industrial use cases, especially in the manufacturing sector. In conclusion, the adoption of LPWA network technologies such as Lora, Sigfox, NB-IoT, and LTM, from the perspective of end markets, has been much slower than the market has anticipated. Now, there are several reasons for this. For many adopters, these technologies were still new and untested by the market, making it risky for large-scale implementations. There was also a lack of maturity in the solution ecosystem that also curtailed growth. And also, there was a certain lack of clarity from end customers when it came to what they really wanted to achieve using IoT, oftentimes resulting in projects getting into pilot purgatories. And there were also delays when we look at certain vertical applications. For example, in smart metering, in many countries, these are still government initiatives that go through lengthy technology evaluation phases and regulatory approvals that can often take anywhere between 18 to 36 months. And this can be sometimes longer in case of new technologies. However, there have been significant progress, especially with LoRaWAN adoption in smart metering, with both device OEM adoption and more recently support for DLMS COSM standard. Now, these are some great progress which will start showing results in the coming years. Furthermore, the initial networks that will be deployed for smart metering use cases will also act as an anchor to enable other smart city applications such as street lighting, parking, urban mobility for shared bikes, and also waste management. Secondly, the impact of the trade wars and the COVID-19 pandemic have proven the advantage of IoT to early adopters, and that are also starting to propel other enterprises to accelerate their adoption of digital tools starting in 2021. Now, as enterprises reassess their supply chains and their delivery models to fulfill changing customer requirements, this will also start fueling demand for remote condition monitoring as a proactive service for predictive maintenance. Furthermore, contextual asset visibility of both stationary and mobile assets indoors and in outdoor environments will also further drive IoT adoption within industrial supply chains. Now, these emerging trends will help LoRa connections from asset tracking overtake smart metering to become the leading IoT vertical by the end of 2024. Thirdly, when we look at LEO satellites, there are some fascinating developments taking place in this market. LEO satellites providing low power sensor to satellite connectivity will largely complement terrestrial IoT networks, but it will also play an integral role in driving adoption in more underserved rural environments and also places that don't have terrestrial LPWA network connectivity or coverage. So finally, based on our assessment, non-cellular LPWA network technologies will have the largest share of overall LPWA network connections for the next few years, and cellular LPWA network connections will only marginally surpass non-cellular LPWAN connections in the end of 2024. And with that, I conclude my presentation. On behalf of ABI Researchers Enabling Platforms team, I thank you all for attending this session. I hope you enjoy the rest of the day's events. Thank you.